Alright, so today we're talking about geometric transformations. We are on day 3, so this is the third episode. We are talking about dilations, otherwise known as a similarity. Alright, so first things first, dilation is just a transformation in which a polygon is enlarged or reduced by a given factor around a given center point. So dilations just make shapes bigger or smaller. We also need to know what a scale factor is. A scale factor is just the common ratio of one polygon to a similar polygon that the shape is dilated by. So, in this example right here, I want to dilate this square by a scale factor of 2. So what that would look like for a motion rule would be for every x and y as it goes to its new points, we are going to multiply by 2. So all you're doing with dilation is just multiplying by the scale factor. So I'm going to take every x and multiply by 2, and I'm going to take every y and multiply by 2. So if I was to figure out what point this is, we have a point at 1 over 2 up. So if it's 1 comma 2, and I'm multiplying both these by 2, 2 times 1 is 2, and 2 times 2 is 4. So I should have a point at 2, so 1, 2, 4. 1, 2, 3, 4. Should have it right there. Alright, same thing here. I got one at 1, negative 1. So multiply those by 2, I should have it at 2, negative 2. Okay, this is 2, negative 2, negative 1. So I should have it at negative 4. 1, 2, 3, 4, negative 2. So again, all we're doing is just multiplying by the scale factor. So we're always going to multiply by 2 in this problem because it's our scale factor. And our last one, negative 2, 2. So we should be at negative 4, 4. So that should be where our points are. Alright? Alright, now this one, dilate by a scale factor of a half. So you'll notice we were multiplying by a whole number here. Now I'm multiplying by a fraction. So if I multiplied by a whole number, you should have noticed that it got bigger. If we multiply by a fraction, it's going to get smaller, because if we're going to multiply by half, it's the same thing as dividing by 2. So it says this would be our motion rule down here. We're multiplying x's by a half and y's by a half. So if you were to do that, this is how it would look. So you notice your triangle got smaller. And if you're doing it with a scale factor of 3, that means you're just multiplying everything by 3. So you should know it's going to get bigger since the scale factor is not a fraction, or it's bigger than 1. So that's how you would look for a scale factor of 3. Alright? Alright, let's take a look at this. I want to dilate this shape, this triangle, by a scale factor of 2. So first of all, you need to ask yourself, is this going to get bigger or smaller? So, since we need to dilate each point by 2, we know that this means the polygon is going to get bigger, because all I'm doing is multiplying everything for each point by 2, because that's my scale factor. So, in order to figure out the new location of each point, just multiply everything by 2, which is the scale factor. So if I go 2 times 2, that's going to give me 4. 2 times 0 is 0. So A prime should be 4, 0. B prime, 3 times 2 is 6. 2 times 2 is 4, so I should have 6, 4. C prime should be 0, 10. Alright? So then I plot those. So 4 to the right, 0 down. 6 to the right, 4 up. And then just nothing, and then 10 up. So that's how I should look. Alright, so you know that it got bigger, so that was good. Alright, dilate by a scale factor of 1/4. So again, you should be asking yourself first thing, is this making my shape bigger or smaller? So since we need to dilate each point by 1/4, that means my polygon is going to get smaller. In order to figure out the new location of each point, just multiply everything by the scale factor. So I'm going to multiply everything by 1/4. Now remember, if you multiply by 1/4, that is the same thing as dividing by 1/4, or dividing by 4. Now the reason that is because we can take, so I'm going to use x as a variable. I'm going to say times 1/4. Now you should have talked about the multiplicative inverse And so what that means is you can change any multiplication to division, and all you do is flip the fraction over. So if I flip this over, I'm going to get 4 over 1, which is just simplified to 4, because then it says it's just 4 divided by 1. So that's why multiplying by a fourth is the same as dividing by 4. So if I just divide everything by 4, I'm going to get negative 2, 0, negative 3, negative 1, negative 3, negative 3, negative 1, negative 2. Okay, and then that's how my shape would look. Okay, so our blue shape got smaller, right there. Right, now we can also find the scale factor of the polygon, or of the polygons, when we have this. So blue in this case is my original, and red is my new shape. Now you might be asking why. How am I going to know which one's what? You need to look at your points. So if this is just a D and this is a D prime, the prime always means that it's moved. So that means the red shape is the new shape. So first you're going to find the coordinates of each polygon and find what changed from the original coordinates to the prime coordinates. So for my blues, I have A at negative 2, 2, B at 1, negative 2, C at negative 2, negative 3, and D at negative 3, negative 2. And then for my red shape, I have A prime at negative 4, 4, B prime 2, negative 4, C prime negative 4, negative 6, and D prime negative 6, negative 4. So now you're trying to figure out a pattern of what happened to every point in this transformation. So ask yourself, how did I get from negative 2 to negative 4? You could have either gone minus 2 or times 2. So let's look at 2 to 4. How did you get from 2 to 4? Well, we said we could have gone minus 2 for the first one. So 2 minus 2 is 0. That didn't work. Or we said it could have been times 2. So 2 times 2, 4. So that might be it. So now 1 times 2, 2. Negative 2 times 2, negative 4. Negative 2 times 2, negative 4. Negative 3 times 2, negative 6. Negative 3 times 2, negative 6, and negative 2 times 2, negative 4. So we know that we have multiplied every single one of these points by 2. So each point was multiplied by 2. Therefore, we have a scale factor of 2. So that's my scale factor. Now, just remember, we always multiply by our scale factor. So if you figured out that, let's say you had A was 6, 3, B was 12, negative 3, and C was 9, negative 6. And then you figured out that A prime was, let's say, 2, 1, B prime was 4, negative 1, and C prime was 3, negative 2. Now, you can look at this and notice that everything's being divided by 2. Now, we just said scale factor is always multiplied, so you can't say divided by 2, but remember we can change it to multiplication and flip the fraction over, and you can make any number of fraction by putting it over 1. So 2 over 1 flipped over is a half. So if you were talking about this pink example right here, the scale factor of this would be a half, because you're always got to talk about multiplication in it. Alright? Alright, let's look at a few examples. So go ahead and try these by yourself. See if you can figure out what the primes are for all these, for number 1 and number 2. And then over here at number 3, see if you can figure out what the scale factor is of the shape. So pause it, come back when you're ready. Alright, welcome back. Alright, so your shape here, you have a scale factor of 3. That means I'm multiplying everything by 3. So if I go A prime, 4 times 3 is 12. Oops. 4 times 3 is 12, and then 2 times 3 is 6. B prime, 3 times 3 is 9. 1 times 3 is 3. And then C prime, 1 times 3 is 3, and 3 times 3 is 9. Right? So if I was to plot this out, it'd go off our grid, but these are our primes. Alright, dilate by a scale factor of a half. That means I'm multiplying everything by half, which is the same as dividing by 2. So A prime would be negative 1, 2. B prime would be 1, 1. C prime, -1, -4, and then D prime would be -2, -2. Alright, and then your last one, you should notice that we multiplied everything by 2, so I have a scale factor of 2. Alright, so that's dilation. So remember, dilation makes everything get bigger or smaller.